All right, so now for the slope fields part of this slope fields lecture. All right, let's take a trip down memory lane, shall we? Do you remember how to do implicit differentiation? Well, you should do it. Do it on this guy right here. Get dy dx by implicit differentiation. Go ahead and do that right now. Pause the video and do it. All right, I'm assuming you are back now after having paused the video and doing that. I wonder how many people just cheat and they just don't pause and they just wait and let me do it. Well, anyway, what you do is you do the derivative with respect to x on both sides. So we've got 2x here. Remember, when we do a derivative of y with respect to x, we're going to pick up a dy dx on it. And remember, the derivative of 4 is 0. Derivative of any constant is 0. And then we solve for dy dx by getting the dy dx terms on the left and everything else on the right. So 2y dy dx equals negative 2x. Dy dx equals negative 2x over 2y. Reduce the... It's getting a little squinchy in there. I'll spread it out. Reduce the 2's and we get negative x over y. All right, so that's dy dx. Slope fields begins the question, could you reverse this process? Could you start with what the derivative is and get what the function is? So this would not be a topic if the answer was no. Therefore, we can probably assume the answer is yes. All right, so the answer is yes, and it leads to a lot of very interesting things. But first, what we do is we analyze dy dx equals negative x over y graphically. We analyze this graphically by looking at something called a slope field. So we start with slope fields because there actually is an analytical method to do this. But slope fields are important for understanding what's going on. Also, there are many equations where we have the derivative of the equation in terms of x and y. That's called a differential equation. All right, so we've got a slope field for the differential equation. Now, when you get to college, you're going to take a whole course on differential equations, and it's going to be hard. Differential equations, but it's fascinating and beautiful. All right, and for the differential equation, the specific differential equation, dy dx equals negative x over y. That's what we're going to do. So slope fields are interesting because there are many differential equations that cannot be solved analytically. And then looking at the slope fields gives you really interesting things. In fact, the entire, one of the newest branches of mathematics is chaos theory, which really emerged in the late 70s and 80s. It came into its own as a branch of mathematics. That all came out of slope fields that have no analytic solutions. Pretty interesting stuff. All right, so what we're going to do is start by doing slope fields for differential equations. So we can do a slope field for anything as long as we have an equation for dy dx in terms of x and y, or it could be x or y. So here's how we do it. We use something called slope field paper. Slope field paper. So I've attached a copy of slope field paper to today's lectures. You should pull it up either digitally or print it. It would be ideal if you can print these. I know printing is sort of the weak link in a lot of people's technological chains. So some people might be reduced to creating your own slope fields, you know, by very carefully doing this. But one thing I do promise to do for you is I will never do more than a 3x3 slope field so that it won't take too long for you to make one of these by hand. You know, I can sketch one out, see by hand in like less than a minute. And it's not too terrible. It's not too shabby. All right. But you could probably make a lot nicer one by taking more than 1 minute to make it. You make your own slope field paper if you want to. All right, but hopefully you'll be able to print this because it makes it a little easier, but I recognize not everybody will be able to. All right, so here we go. We're going to do slope field paper. In almost all of the problems I'm going to do, just as a matter of practicality, I'm only going to look at from 1, 2, 3, from negative 3 to 3, and from negative 3 to 3. All right. Bear that in mind when you're doing the homework, because in the homework I'm going to have you do a bunch of these. Only go from negative 3 to 3. Don't go from negative 5 to 5. I mean, you can if you want to. Some people find it meditative, but for most people, those, you know, that's going to be 100 little slopes to draw. It's a little much. All right, it's bad enough that you got 36 of them to do. Okay, so what do we do with this slope field paper? Well, I'm glad you asked. I will tell you. So you go to a point on the graph. So let's start with negative 3, 3. All right, there's negative 3, 3. All right, and what we're going to do is we're going to take this dy dx, and we're going to evaluate that at the point negative 3, 3. All right, so what's it going to be? It's going to be negative, the x is negative 3 over the y, which is 3, so it's going to be 1. All right, so what that means is that at this point, I'm going to draw a little slope that has slope 1. Now I can be, and I like to be, really precise by using a ruler to create a slope of 1 by looking at the way the dots lay out, but then I just make a little slope like that. I'm not going to make a gigantic slope, just a little slope like that. All right? Now we just go to the next point. We're going to go to negative 2, 3. All right, so now we're going to go to negative 2, 3, so that is here. All right, so I'm going to do dy dx of negative 2, 3. All right, so that's going to be negative 2 over 3, which is 2/3, okay? Now, see, I can still make that 2/3 slope pretty accurately because it means I'm going to go up 2 and over 3, right? So if I go up 1, 2 and over 1, 2, 3, that puts me here, and that's my slope, right? So I can actually be pretty precise about that slope. Did I do it right? 1, 2, 1, 2, 3. I did it wrong. Ah, geez. That really goes like that. Okay, well, I guess I'll live. All right. Next point is going to be negative 1, 3. Negative 1, 3. So a little point there. Remind myself of where I'm at. So now I'm going to do dy dx of negative 1, 3. So that's going to be negative 1 over 3 equals 1/3. So that slope is going to be 1/3. So when I'm here, I'm going to go up 1 and over 1, 2, 3. From this point, I went up 1 and over 3, and I got there. So try not to make a big mess. And there's my slope like that. All right. Next one, we'll just do one more. We'll do the point 0, 3. 0, 3. dy dx at 0, 3. So that's going to be negative 0 over 3, which is 0. So that's the slope 0, which is horizontal. And I'll just make a nice horizontal slope right there. All right. Now, if we were in class, I would give every person in the class one of these points to do, and we will all do them. We're not in class, so what I'm going to do is I'm going to do this all myself, and then I'm going to show you the result. And you can sort of work through, maybe use pencil, or, you got lots of these. You can do it over again, and you can print some more, hopefully. So see if you can finish out this using this process. Fill out this graph. See if you get the same thing I get.